Hello students, welcome back to your favorite and India's most affordable learning platform, Physics Wallah. So in the last session, we have started the system of particles and center of mass, already 3 lectures completed. So now today we are going for the lecture number 4, where we are going to concentrate majorly on what are the collisions and what are elastic collisions and inelastic collisions and the collisions in 2D. See, so today's class it's just going to be the elastic collision. In inelastic collisions and coefficient of restitution, so we'll discuss it in the next session. Okay, so this topic, today's session and tomorrow's session, it's going to be the end of this chapter. So total 6 lectures for this. It's fourth one right now. Yeah, so total 5 lectures for this chapter. So after that we'll start the rotational motion. Okay, so with the rotational motion we'll complete the complete mechanics. So then we'll move on to the heat and thermodynamics part, or else fluid mechanics. Okay, chalo guys, gravitation is also there. We have to complete the gravitation as well, right? Chalo. So without wasting much time, let's get into the today's topic. So that is elastic collisions. So as usual, I just need your attention for the next 1 hour, guys. So just be with me, avoid all the disturbances around you. Okay, so and at the end of the session, it's very important to prepare your own short notes. Already we have completed some 5 or 6 chapters from starting, right? So all these chapters short notes you should have, not the mind map which is available on the internet, or not the short notes which is available on the internet, no, or someone who wrote, no. You have to prepare your own short notes. That's my sincere advice, guys, because when you are writing the complete chapter summary on your own, so you will be able to recollect all the formulas. If you are not getting that formula now, so definitely you are not going to get it in the exam also. So that's where you will get to know, so yes, I have to focus at this on this formula related to this chapter. Okay, you will realize and you will analyze. Okay, so that's the importance of short notes preparation. Clear? Chal. So let's go for the basics of collisions first. So in physics, see, when a collision will happen, like when we say a collision has happened, so when do we say? Whenever the momentum of the body changes, if the momentum of the body changes, so then we say the collision is happened. Okay, collision is said to happen when momentum of one body changes due to the another body. Let's suppose, so if there is a body, one body, and this is another body, this is of mass m1, this is of mass m2. So now it is moving with some velocity v1, and then it hits with the another body of mass m2. So then, so the body m2 moves with some other velocity v2. So here the momentum changed. So when the momentum of one body changes due to the another body, so that is said to be the collision happened. Then we say the collision happened, right? So the concept in any kind of collision, so there is no external force. So till now we have seen, so if there is no external force, if F external is 0, so then can we say that, so the net momentum of the system is going to be constant? The net momentum of the system is going to be constant. So that means the momentum is conserved, the linear momentum is conserved. Whenever there is a no external force acting on the body, we can say that, so the net momentum of the system is going to be constant, which means that, so the initial momentum of the system will be equal to the final momentum of the system. So that's what I wrote here. So linear momentum remains conserved throughout any collision. So that means whenever there is a collision happen, you can blindly consider that, so the momentum is going to be conserved. The initial momentum will be equal to the final momentum. Okay, clear? Understood this slide? First one, just basics. So let's move further. So now let's classify the collisions, guys. So we have 2 types of collisions majorly. So one is the elastic collision and the another one is the inelastic collision. So in elastic collision or inelastic collision, if it is collision, whatever the type of collision will be, no problem, just understand the word, just recognize the word, the collision. So whenever the collision happen, you can simply say that its momentum will be conserved. See here, momentum remain conserved. So the momentum remain conserved. So whether it's going to be the elastic collision or inelastic collision, you don't worry about that. So if it is the collision, so you just blindly write, so the momentum is going to be conserved. The initial momentum will be equals to the final momentum. So that means, so the momentum, if you draw the momentum versus time curve, so the momentum remains constant with the time. The momentum remains constant with the time. So for the elastic collision, see, this graph is also important. So which of the following will be the graph of momentum versus time for the elastic collision if they ask? So this is, and even if it is for the inelastic collision also the same graph, because the momentum will be conserved in collisions. So it's going to be momentum versus time, it's going to be constant again, like this. Clear guys? Momentum conserves in both the cases. Now, so then what is the difference between elastic and inelastic collisions? Are how can we differentiate between these two? So by checking their energies. So the kinetic energy initial will be equals to the kinetic energy final. So this is in the case of elastic collision. So that means I can say that, so the kinetic energy versus time graph, so the initial kinetic energy, the final kinetic energy should be same with respect to the time. So but in between, so the energies can be decreased, but the initial and final should be same. See here, so initial and final should be same, understanding? So but in between it can decrease. Okay, so in between it can convert to another form of energy, but the total energy remains same of the system. Okay, so but in the inelastic collision, so the initial kinetic energy will be greater than the final kinetic energy. So here if I draw the kinetic energy versus time graph for the inelastic collision, so where the kinetic energy decreases, so that means in this particular case, so the energy loss takes place. What happens? So the energy loss takes place. Energy loss takes place in the case of the inelastic collision, whereas in elastic collision the kinetic energy initial will be equals to the kinetic energy final. So and momentum will be conserved, so the initial momentum will be is equals to final momentum. So clear everyone? Understood now what's the difference between so the elastic collision and inelastic collision, right guys? Chalo, so let's move further. So now in a perfectly inelastic collision, so the colliding body sticks to another and move with common velocity v. So that means, let's suppose here is a bullet, okay, and here is a block of mass m. So now, so the bullet is moving with some velocity u, and then so let's suppose this is at rest. So now after collision, in a perfectly inelastic collision, so what happens is this bullet comes and hits a block and it will combine with the block. So that means it will be struck into the block, and then they both move with a common velocity v. So they both move with the some common velocity v. See here, in a perfectly inelastic collision, the colliding body sticks to another one. So the colliding body sticks to another and move with common velocity. Now these two will move with the same common velocity v. So v is a common velocity of bullet and block. Clear? Understood guys? Everyone? Chalo. So let's move further. So now, so in elastic collision again, so we have two types. So one is a head-on elastic collision and oblique elastic collision. So here both are elastic collisions only. So these are the types of elastic collisions we are talking about now. So what does it mean by head-on elastic collision? So for that, so you should understand one term, that is the LOI, the line of impact. So it's, what is LOI? The line of impact means here it is the common normal line passing through center of mass of two bodies. So this is a LOI. See here. So in the head-on collision, so you'll understand, just see for 1 minute here. So the velocity vectors of the colliding bodies are along the line of impact. See here. So this is the first body whose velocity is like this, and this is the second body, so whose velocity is like this. So now if I combine their center of masses, see here, so the common normal passing through, see here, the common normal passing through the center of mass of two bodies, the yellow color line is the line of impact. So if you observe, so the velocity vector of the body A, let's consider this is the body A and consider this is the body B. So the velocity vector of the body A and velocity vector of the body B, they both are along the line of impact. Their velocity vectors both are along the line of impact. Yes or no? Understanding? So then the collision that is said to be happen in this particular case is called the head-on collision. In this particular case, whatever the collision that happens, that's a head-on collision, which is elastic collision only. Right? Chalo, next. So the oblique collision, next one, the oblique collision. So where the velocity vector of both or any other body is not along the line of impact. So first draw the line of impact for this. So this is the center of the first body, this is the center of the second body. So now connecting the centers, so let's draw a line. Connecting the centers, let's draw a line. So this is the line of impact now. So this is the line of impact. Now the body 1's velocity will be in this direction. So body's 2 velocity is along this direction. So that means their velocity vectors are not along the line of impact. Previous case, so their velocity vector and this one, so they are along the line of impact. So that's said to be the head-on collision. So where here in the second case, so the line of impact is this way and the velocity vectors are to the right. So in this particular case, so the velocity vectors are not along the line of impact. So, so then such collision is said to be the oblique collision. Okay, clear guys? Understood? Sure. Chalo, so let's move further. So now, so in the elastic collision, so we are talking about the head-on elastic collision. So if it is elastic collision, two things will happen. So what are they? So one is the momentum will be conserved. One is the momentum conserved. And then the second thing, so the kinetic energy initial will be equals to the kinetic energy final. The kinetic energy will be initial will be equals to the kinetic energy final. So now, so the first thing I am considering in the head-on elastic collision, so let's take, so the momentum conserved. In the first case, let's write, so the momentum conserved. So if the momentum is conserved, so the initial momentum will be equals to the final momentum. So I am writing, so the momentum of the body 1, so m1 u1 plus, so the m2 u2. So combinedly these two, this is the elastic, initial momentum. So this is before collision. Before collision. Now, so this is after collision. This is after collision. Clear? Chalo. So let's move further now. So m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. m1 v1 plus m2 v2. So now what I am doing is, let's write, bring this m1 v1 term to this side. So I can write m1 v1 minus m1 v1 and send this m2 u2 term to that side. So m2 v2 minus m2 u2. So let it be. So then next I'll write, so m1 take it out. So here u1 minus v1 is equals to, so m2 take it out, so which is v2 minus u2. So v2 minus u2. So let it be the equation number 1. So consider this as a equation number 1. So this is the momentum conserved. Okay. So then for the same collision, if I take, so the second thing, the kinetic energy initial is equals to, So the kinetic energy final, right? So the first body's kinetic energy. What is the first body's kinetic energy? So half m1, half its mass is m1, its velocity is u1, half m1 u1 square plus half m2 u2 square, second body's velocity, kinetic energy. So this is before collision. So and the kinetic energy after collision, their velocities are v1 and v2. So now I can write half m1 v1 square plus half m2 v2 square, right? So from here, so let me write, bring this m1 or else take half common and cancel both either side, right? So now let's write the terms again. M1 u1 square plus m2 u2 square is equals to m1 v1 square plus m2 v2 square. So here bring this to this side. So m1 u1 square minus m1 v1 square is equals to m2 v2 square minus m2 u2 square, right? So from here, so let's write m1 common here. So I can write u1 square minus v1 square. So is equals to m2, take it out. So here v2 square minus u2 square, right? So chalo. So let it be equation number 2. So now what I am doing is, let's divide equation 1 by equation 2. So we have got equation 1 and equation 2. So let's divide their respective LHS and RHS. So if you write, let's divide 2 by 1 better instead of 1 by 2. So let's go for 2 by 1 for easy calculations. So let's write equation 2 by equation 1. So what's the equation 2? So the m1 into, so u1 square minus v1 square by, so what's the LHS of this one? m1 into u1 minus v1, u1 minus v1. So here, which is equals to m2 into, so v2 square minus u2 square by, so here the next one, m2 into v2 minus u2, m2 into v2 minus u2. So now see here, so m1 cancel, m2 cancel. So now I can write u1 square minus v1 square. So which we can write it as u1 plus v1 into u1 minus v1 by, so u1 minus v1, right? Chalo. So next I can write here, so v2 minus u2 into v2 plus u2 by v2 minus u2. So here v2 minus u2. So u1 minus v1 cancel. So I can write, so u1 plus v1 is equals to v2 minus v2 plus u2. So bring this u2 to this side now. So u1 minus u2 is equals to v2 minus v1. So remember this. So this is the important result everyone should remember. Okay. So the u1 minus u2 is equals to v2 minus v1. So what is this, sir? So here this u1 minus u2 is nothing but it's a relative velocity of approach. So what is this? So this is a relative velocity of approach. The relative velocity of approach u1 minus u2 will be equals to the relative velocity of separation. So what is this? This is a relative velocity of separation. Relative velocity of separation. This is the relative velocity of separation, v2 minus v1. So before collision, it's the relative velocity of approach, and after collision, it's the relative velocity of separation. Understanding, guys? Clear? So this is about the elastic collision, head-on elastic collision. So here the momentum will be conserved and the kinetic energies are going to be equal, initial and final, right? And then we have got this relation, important one. You guys should remember this. Okay? Chal. So now, so next, sir, see here. So this is the body of mass m1. You said its velocity is u1, and this is a body of mass m2, and then whose velocity is u2. And after collision, So their velocities, this is v1 velocity and this is v2 velocity, v1 and v2. Sir, do we have any formula to find the velocities after collision? We have got the relation between, so the relative velocity of approach and relative velocity of separation, they both will be equal. But what are the velocities of individual bodies after the collision, sir? Is there any formula for v1 and v2? Yes. So now let's write the formula for, so v1 and v2. So where v1 and v2 are the velocities of two bodies, collided bodies after the collision. So let's write the v1 formula. So the simple way to remember, so the v1 is equals to, so m1 minus m2 by m1 plus m2 into u1 plus, so 2m2 by m1 plus m2 into u2. That's it. Okay, so this is a v1 velocity. So then let's write the v2 velocity. So here v2 means, right, m2 minus m1 by, so denominator m1 plus m2, so here into u2 plus here 2m1 by m1 plus m2 into u1. So simply if it is v1, so the first v1, so the first terms are going to be 1 minus 2 by 1 plus 2 into 1. So and second terms like 2, 2. So if it is the velocity of the second body, so 2 minus 1 by 1 plus 2 into, so into u2. So 2, 2, 2, 2 first, like that. So 1, 1 first, 1. So then 2. So then see here, so here 2m1 by m1 plus m2 into u1. Clear, guys? Understood this formula? Everyone? Done? Chalo. So if I say, let's suppose this is a x body. So let's write the formula to remember it easily. Let's write it in another variables. So x body is moving with a velocity a. So and y body is moving with a velocity b. So now after collision, so let's suppose, so the x body has got some velocity v1. So the y body has got some velocity v2. So now if I asked you to write what is the v1 velocity, so how do you write the v1 velocity? So simply m1 minus m2, so that is x minus y by x plus y into, so what is u1? u1 is a plus, so the next one 2m2, so m2 means y, this is m1, this is m2, right? 2y by m1 plus m2, so x plus y, so into, so the u2, so what is u2? b. That's it. So this is the v1. So now if you have to write the v2 formula, so how do you write? m2 minus m1, which is y minus x by y plus x or x plus y, right, into, so u2, so u2 means b, so plus, so 2 m1, so what is m1? X by, so x plus y into, so u1, so what is u1? a. That's it. Clear, guys? Understood the formulas? So these formulas you should remember. Done? Clear till here? Right? Sure. Fine. So let's move further. So in a perfectly elastic collision, so the relative velocity of approach will be equals to relative velocity of separation. Yes. So let's suppose this is a body of mass m1 whose velocity is u1. So this is a body of mass m2 whose velocity is u2. So this is before collision. And after collision, so this is a body of mass m1, so whose velocity has become v1. So m1, so whose velocity is v1, and m2 whose velocity is v2. So then you can say that the relative velocity of approach u1 minus u2 is equal to the relative velocity of separation v2 minus v1. So this is a relative velocity of approach. Relative velocity of approach is equals to the relative velocity of separation. Relative velocity of separation. Clear? So we are going to do the question, just practice the formulas, guys, now. Done? Everyone? Sure. So let's move further. So let's solve the first question. Try to do this question on your own. Try to do this question on your own, guys. Two particles of mass m and 2m moving in opposite directions collide elastically with velocities v and 2v. So find their velocities after collision. So there are two bodies whose mass is m and the other one is of the mass 2m. So let's write here. So this is of the mass 2m, right? So then, so they move with the velocities v and 2v, so in opposite directions. So now, what are their velocities after the collision? So let's suppose the body mass m, so will move with a velocity v1, and body of mass 2m, it moves with a velocity v2. So we had to find what is v1 and v2. So direct formula based question. So what's a v1? So v1 formula, we know that v1 is equals to m1 minus m2. First let's write the formula, by m1 plus m2 into u1 plus 2m2 by m1 plus m2 into u2, right? So chalo. So now substitute the values. So what is m1 is m, what is m2? So 2m, m1 plus m2, m plus m, 3m. So into what is u1? u1 is v velocity. So what you do is consider the right side direction as positive. Okay, chalo. So then plus 2 into, so what is m2? m2 body mass is 2m. m1 plus m2 is 2m plus m, 2m. So u2 I am taking it as minus 2v. Why is minus 2v, sir? Because it is moving in opposite direction, left side. So right side direction I consider it as positive, right? So now you do the calculation. So we will get, so v1 is equals to, so m minus 2m, so which is minus m by 3m into v. So here m cancel, so we can write it like, so 2 into 2 4, 4 into 2, so minus 8. So just write minus 8, this, yes or no? So 2 into 2 4, 4 into 2 minus 8, so by 3v, right? So here m cancel, so here I can write minus v by 3 minus 8 by 3v, or minus 8v by 3. So which we can write it as, so minus 9v by 3. Yes, so which is nothing but minus 3v. So the first one's, the first body velocity is minus 3v. So this minus indicates, so the first body moves with a velocity v1 to this side. So with how much velocity? So with 3v velocity, so left side after collision. So this moves backwards with a velocity 3v. So this minus indicates backward, this direction. Okay, so the first one 3v, so 3v is here. So you can eliminate the first two options, right? So now let's go for the v2. Direct formula based, you can do it directly. So v2 is going to be m2 minus m1 by m1 plus m2 into u2, right? Plus 2m1 by m1 plus m2 into u1, right? So now substitute the values. m2, so 2m minus m, directly I am writing 2m minus m is m. So by m1 plus m2, 3m. So what is u2? So u2 is minus 2v, left side. So plus 2m1 is m by, so m1 plus m2, 3m. So what is u1? V velocity. So here m cancel, m cancel. So here it is going to be minus 2v by 3 plus 2v by 3. Yes or no? So both cancel. So this is 0. So that means the second body's velocity has become 0. So option 2 is the correct one. Clear, guys? Understood? So the first body moves to the left with a velocity 3v, and the second body moves, it's not moving, it's going to be at rest, 0. Understood? Chal. That's the first question. So now, so in elastic head-on collision in 1D, so the same formulas I am going to write. So here nothing to remember. The first thing is the relative velocity of approach is equals to relative velocity of separation. V2, V1, U1 minus U2 is equals to V2 minus V1. And then, so the velocities after collision V1 is equals to M1 minus M2 by M1 plus M2 into U1 plus Yes, so m2 2m2 by m1 plus m2 into u2. Yes, so then, so the v2 will be equals to m2 minus m1 by m1 plus m2 into u2 plus 2m1 by m1 plus m2 into u2, sorry, u1. Clear? Understood, guys? Everyone? Chal. So these are the formulas in head-on elastic collision you have to remember, and we have to solve the questions related to this. So let's move further. So let's take one more question. Find the velocity of 2 kg ball after collision. So this is u1 velocity, which is 5 meter per second, u2 velocity, that is 2 meter per second. So 2 kg block velocity we have to find. So let the 2 kg block velocity be v1. So we just need to find the v1. So what is the v1 formula? Just now we wrote. So m1 plus m2, sorry, m1 minus m2 by m1 plus m2 into u1 plus m2 m2 by m1 plus m2 into u2, right? So now substitute the values. m1 minus m2, so 2 minus 3 by 2 plus 3 into, so what is u1? So right side direction I am taking it as positive, so this is going to be plus 5, right? So plus 2m2, 2 into m2 is 3 by m1 plus m2, so which is 2 plus 3, so into u2. So what is u2? 2. So from here this is going to be minus 1 by 5 into 5 plus, so this is 6 by 5 into 2. So 2 into 3, 6 by 5 into 2. So this is going to be minus 1, and this is going to be 12 by 5. So minus 1 plus 12 by 5. So it's going to be 5 is the LCM. So it's 5 times minus 5 plus 12. So which is 7 by 5 meter per second. Yes or no? 12 minus 5, which is 7 by 5. So this is its velocity is 7 by 5 meter per second. We got positive, that means it's moving in the right side direction. So 7 by 5, option 3 is the correct one. Understood? Direct formula based question. Let's see the next question, guys. So what's the question says? A smooth sphere of mass m moving with a velocity u directly collides with another sphere of mass m which is at rest. So this is a sphere which is of capital M mass, so moving with a velocity u, and it's collided with, so there is small mass m which is at rest, so that means its velocity is 0. So that means I can say u2 velocity is 0. So after collision their final velocities are, after collision, so their final velocities are v dash and v. So this is of the mass m, so its velocity is v dash. So the small m mass velocity is v. So we have to find the value of v. So the small v means v2 we have to find. So just directly write the v2 formula. See, small v is the velocity of the second body, so which is nothing but after collision this is a v1, so which is v dash, this is v2 which is v, right? So we have to find v2. So write the v2 formula, which is m2 minus m1 by m1 plus m2 into u2 plus 2m1 by m1 plus m2 into u1, right? So now m2 minus m1, so m2 is small m minus m1 capital M by, so see, shall I write this whole term as 0? Shall I write this whole term as 0? This whole term, because the u2 is 0, so this whole term will become 0. Now directly take this one, 2 into, what is m1? m1 is capital M by m1 plus m2. So m1 plus m2 means small m plus capital M into, so what is u1? So u1 is u. So this is a velocity v2. So 2 u capital M by m plus m. So it should be m plus m in the denominator, but m plus m is not there in the options. So let's do one thing. Let's divide it by the small m mass or capital M mass. So let's divide each term by numerator and denominator by the capital M mass, so that I'll get, so capital M cancel. So here small m by capital M plus 1. This option is there, check it. 2u by 1 plus small m by capital M. So if I divide it with small m, so then I'll get 2mm by, so it's not there. So this option is only there. So I'm doing nothing here. So just I'm dividing the numerator and denominator by capital M, so that capital M cancel in the numerator, and in the denominator small m by capital M plus capital M by capital M. Okay, small m by capital M, and m by m is 1. That's it. So into u. So which is 2 into u. So which is the option 3. 2u by 1 plus small m by capital M. Clear, guys? Understood? Sure. So let's go for the next question, the question number 4. So what's the question says? Find the value of m. So before collision, this is a 1 kg block. So whose velocity is u? So this is the at rest, and so this is a m1 block whose velocity is u by 3. So m2 block velocity v. See, we know the velocity v1, right? We have to find the value of small m. So let's do one thing. So consider this side direction as positive. Let's write the formula for v1. So what's the v1 formula? v1 is equals to m1 minus m2 by m1 plus m2 into u1 plus 2m2 by m1 plus m2 into u2, yes. So now m1 minus m2, see what is the v1 value? v1 I am writing it as minus u by 3. So why minus, sir? Because it is to the left side. So right side direction we consider it as positive, right? So then so I can say that this whole term will become 0, because u2 is 0, u2 is 0, u1 is equals to u. So now this is equals to m1 1 kg minus m2, let it be m. So here m1, so 1, so m2 m, so into what is u1? u1 is u. So now let's write u cancel. So minus 1 by 3 is equals to 1 minus m by 1 plus m. So now let's do the cross multiplication, so that we get, so minus 1 into 1 plus m is equals to, so 1 minus m into 3, right? So from here we get minus 1 minus m is equals to, so 3 minus 3m. So bring all the m terms to one side. So bring this m term to this side. So 3m minus m is equals to, send this to that side. So 3 plus 1. So which is 2m is equals to 4. M is equals to 2. So the mass of the second body is 2 kg. Option 2 is a correct one. Clear, guys? Understood? So let's go for the next one. So the question number 5. So what's the question says? So which was asked in NEET 2019. A body A of mass 4m moving with a speed u collides with another body of mass 2m which is at rest. So the collision is head-on and elastic in nature. So head-on collision and elastic in nature. So after the collision, the fraction of energy lost by the colliding body A. So the fraction of energy lost by the colliding body A. Energy lost by the colliding body A they are asking. See here. So the first thing, this is of body A which is of mass 4m, and then so another body B which is of mass 2m. So this is at rest, and then this is moving with a velocity u. So collided, and after collision, so the 4m mass will have the velocity v1. So and 2m mass, let's suppose its velocity v2. So we need, after the collision, what is the fraction of energy lost by the body A, right? So we need its energy lost. So let's find first what is v1 velocity. Let's first find, so what is v1? v1 formula is equals to m1 minus m2 by m1 plus m2 into u1, m1 plus m2 into u1 plus, so here 2m2 by m1 plus m2. So 2m2 by m1 plus m2 into u2. Yes. So as the second body is at rest, so I can consider this whole thing to be 0. So now let me find what is v1. So the v1 is equals to m1 4m minus m2 2m by m1 plus m2, 4m plus 2m, 6m, into what is u1, u. So from here the v1 is equals to 2m by 6m into u. So m cancel, so 1 by 3, so which is nothing but, so the v1 velocity is, its velocity is, we got u by 3, right? So now see what is the energy lost, fraction of energy lost by the body A. So what is the initial energy of the body A? It is moving with u velocity. So let's find, so the kinetic energy initial of the body A. So what is the kinetic energy initial? Half into its mass. So its mass is 4m. So into its velocity u square, right? So let it be. So or else you can write, so 2 ones are 2 twos are, which is nothing but 2m into u square we got, initial kinetic energy. And then after collision, what will be its kinetic energy? So the kinetic energy final of B. So then, so what is the half into its mass is same 4m. So its velocity is what after collision? U by 3. So then u by 3 whole square means u square by 9. So 2 ones are 2 twos are. So which I can write it as 2m into u square by 9. So if I consider this as x, so this will be x by 9. Yes or no? So if I consider 2m u square as x, so this is going to be x by 9. So now what is the fraction of energy lost by the colliding body A? So therefore the energy lost is equals to, so KEF minus KEI by, so the original which is KEI. So I can write here x minus the final is, what is that, x by 9 minus, sorry, energy lost is nothing but initial minus final, you write, because final is less, right? So let's write, so KEI minus KEF by fraction, they are asking the fraction of energy lost. So first let's find the energy lost, which is equals to x minus x by 9. So which is 9x minus x, which is 8x by 9. So this is the energy lost. So now what is the fraction of energy lost? Fraction of energy lost, which is equals to, so the energy loss 8x by 9 by the original energy. So then x gets cancelled. So it's going to be 8 by 9. So the correct option is option 4. Clear? So what's the fraction of energy lost? So it's a 8 by 9. Understood? First see what kind of energy the moving body possesses, only the kinetic energy, right? Here there is no, they did not mention whether it is at some height, so or it is attached to the spring, they did not mention anything. So what kind of energy it possesses? So it, as it is moving, it will have kinetic energy. So now for the same body I have to find its final kinetic energy. So for that I need its velocity after collision. First we discussed, first we calculated its velocity after the collision. So then we calculated its initial kinetic energy and final kinetic energy. So now what is the fraction of energy lost? So it's a loss in energy or energy lost by the original kinetic energy. So that's what I wrote. Clear? Understood? Chalo. So this question was asked in NEET 2019, guys. Done. Chalo. So let's move further. Now let's take some special cases of head-on elastic collision. So if the two masses are identical, so if two colliding bodies are identical, two colliding bodies are identical, two colliding bodies are identical. So let's say their masses are m1 is equals to m2. So let's say is equals to m. So they both are same, which is equals to some m value. So that means this is of body of mass m, this is of body of mass m. So identical bodies. So now after collision, so what will be their velocities? So after collision, what will be their velocities? So let's find. So the v1 velocity first. So v1 velocity, what is the v1 formula? m1 minus m2 by m1 plus m2 into u1 plus, here it is 2m2 by m1 plus m2 into u2. So then shall I say that this value will become 0? Why? Because this is m, this is m. m1 minus m2 means m minus m 0. So directly I can write v1 is equals to, so 2 into m2 is m, right? So here 2 m1 m1 plus m2 means 2m into, so u2. So that means, so the v1 velocity is equals to u2. So let it be. Now, so the next, let's write what is the v2 velocity after collision. This is v1. So this is v2, right? So then, so v2. So let's find the v2. So v2 is equals to m2 minus m1 by m1 plus m2 into u2 plus 2m1 by m1 plus m2 into u1, right? So from here, so what is this term will become 0 because m2 minus m1, so both the bodies are having same mass, so it's going to be 0. So 2m1, m1 is m by m1 plus m2, so 2m into u1. So that means v2 will become, so v2 will be equals to u1. So what you are, this is v1 is equals to u2, v2 is equals to u1. So what you can observe guys here, so initially let's suppose it is moving with u1 velocity, it is moving with some u2 velocity. So then after collision, so their velocities will be interchanged, yes or no? So before collision, so body 1 mass is u1, body 1 velocity is u1, body 2 velocity is u2 before collision, and after collision body 2 has got, so the velocity u2, okay? So whereas body 1 has got velocity u2 and body 2 has got velocity u1, so which means that, so their velocity is interchanged after the collision, I can say, yes or no? So there, so if two colliding bodies whose masses are same, our bodies are identical, so you can directly write that, so their velocities will be interchanged, so their velocities will be interchanged, so you can directly write that. So write that statement. Clear? Chalo. So this is the first condition. So now let's go for the second case where m2 block is far greater than the m1 and its velocity u2 velocity is 0. Consider, let's suppose this is a m1 block, okay, and there is, so m2 block which is very very large. See here, m2 is far greater than m1, m2 is far greater, so and it is at rest, the second one is at rest, and let's suppose this is moving with some velocity u1. So then after collision, so the small block m1 and the big block m2, so what are its velocities? See, when m2 is far greater than m1, first thing you have to understand is, if m2 is far greater than m1, so then we can say that m1 almost tends to 0. m1 you can neglect, it is negligible, m1 is going to be negligible. So now let's calculate what is v1 and v2. So let's suppose its velocity v1, its velocity v2. So the v1 velocity will be m1 minus m2 by m1 plus m2 into u1 plus, so 2 m2 by m1 plus m2 into u2. So now substitute the values. So what is m1 minus m2? So m1 is m1 I said almost negligible, so 0, you can take almost 0, minus m2, so let it be m2 itself, by m1 plus m2, so 0 plus m2, so no, m1 is 0 plus m2, so which is m2 into, so what is u1? So let's its velocity be u1. As second one is at rest, so this is going to be 0, so that means the v1 is going to be, so here minus m by 2, m2 gets cancelled, so it's minus 1 into u1, which is minus u1. So this is a v1 velocity. So now let's calculate v2. So what is v2 formula? Which is m2 minus m1 by m1 plus m2 into u2 plus 2m1 by m1 plus m2 into u1. Yes. So now substitute the values, m2 minus m1. So m1 is almost negligible, 0. So in place of m2, just write m2. So this is 0 by m1 plus m2. So which is m2? Yes or no? So u2 is 0. See, you know that this u2 term is 0. So this whole thing will become 0 directly. And then 2 into m1. m1 is almost 0. So 2 into 0 means 0. So that means this term is 0, this term is 0. So directly shall I say this is going to be at rest, the second one, right? So here what sorry guys. So here what calculation, what's the understanding? Tell me. So what you can understand from here? First, so if the block 2 is much larger than the block 1, and so the block 1 velocity is u1, after collision, so the block 1 moves with, so the same velocity v1, so to the back side. So it moves to the same velocity, with the same velocity comes back. So with u velocity it returns back. Okay, so and then so the second one will be at the rest itself. So I'll tell you the example for this. So the example is, let's suppose, so this is of ball, some mass 1 kg, and here is a wall. Here is a wall. So this wall is going to be at rest. Yes or no? So the wall is at rest. So then this body is moving with some 5 meter per second. The ball is moving with some 5 meter per second. So see, m1 is very negligible to compared to the m2, because the wall will be of heavier mass. So the ball is of smaller mass. So m1 is almost negligible to m2, right? So that's why, so when it moves with 5 meter per second, after collision, so there is no loss of energy here. So then it comes back with the same energy, 5 meter per second. So that's what I said, u1 velocity it is going, and with the same u1 velocity it strikes back, comes back. Okay, where the wall is going to be still at rest. Understood guys? Clear? Sure. So now let's consider the third case, where m1 is far greater than the m2 and u2 is 0. So let's consider. So here is the block m1, this is of block m1, and then so this is of small mass m2. So this is before collision. So let's consider this is moving with some velocity u1. So and it is at rest, the second body is at rest. So now after collision, so the m1 block, so it moves with some velocity v1, let's say. So the m2 block, so let's say it moves with some velocity v2. So now let's calculate what are v1 and v2 values. So first thing, if m1 is far greater than m2, so then we can say that m2 is almost negligible, so tends to 0, right? So first v1 velocity you calculate. V1 is equals to, so m1 minus m2 by m1 plus m2 into u1 plus 2m2 by m1 plus m2 into u2 into u2. So from here, so I can simply say that the second one is at rest. So that's why this whole thing will be equals to 0. This whole thing will be equals to 0. And m1 minus m2, so this is m1 minus m2. So I can neglect m2. So that's why in place of m2 I can write 0, because m2 is very smaller, right? So that's why, so here m1 by m1 into u1. So these two cancel. So the v1 will be equals to u1. So its velocity before collision and after collision will be same. The heavier mass velocity before collision and after collision it's going to be same, right? So then the next, let's calculate the v2. So v2 is equals to m2 minus m1 by m1 plus m2 into so u2 plus, so 2m1 by m1 plus m2 into u1. Okay, so from here what is m2 minus m1? So m2 minus m1, see m2 is almost 0, so in place of m1 let's write minus m1. So 0 minus m1 is minus m1. So m1 plus m2, so let's write m1 plus m2. So into, as u2, see directly, no need to do this. So as u2 is 0, so this whole term will become 0. As u2 is 0, so this whole term will become 0. And then 2m1, so let it be by m1 plus m2. So m1 plus m2 is 0. m2 is going to be 0 into u1. So that means m1 cancel, 2 u1. So that means after collision, so the second smaller body's velocity is becoming twice the first body's velocity. So let me tell you the example for this case. Let's suppose, so there is a large truck, so which is moving with some velocity u, and then so here is some bike. So let's say here is some bike, so which is this is a bike. Okay, so now after collision, this is initially at rest. Now after collision, so let's suppose the bus is moving with some 50 meter per second, so it is initially at rest. So after collision, so the bus or truck moves with the same velocity. But the bike moves with a velocity of, so how much? So 2 times of this, so 100 meter per second after collision. Understood, guys? So the bike moves with a velocity of 100 meter per second. Understood? Clear? So let me summarize these 3 cases, guys. See here. So let me summarize these 3 cases. So here, first case, if 2 bodies are identical, then so before collision and after collision, their velocities will be interchanged. So if it is moving with u1 velocity, if it is moving with u2 velocity, and then so after collision m1 will move with u2 velocity and m2 will move with u1 velocity. Their velocities will be interchanged. So this is the first case. And then so the second case, if m2 is far greater than the m1 and u2 is 0, so in that particular case, let's say this is of mass m1, so this is of larger mass m2. So the before collision, this is moving with some velocity u1, so this is at rest. So then after collision, so the m1 block comes backward with the same velocity u1 and m2 block will be still at rest. So you can just take the wall and ball. You can just imagine like this, a wall and ball, right? So and then so the third case, if m1 is far greater than the m2 and then u2 is at rest, so second one is rest. So this is of block m1, so this is of block m2, so this is at rest, and then so this is moving with some velocity u. So in after collision, so the m1 block will move with the same velocity. There is no change in velocity of the first block, the bigger block, so same u1 velocity. But m2 from rest, it moves with a velocity 2 times the initial velocity of the larger block, so it moves with a velocity of 2u. Clear? So all these 3 cases, so some questions you can directly answer with these 3 cases. Okay, so I'll give the examples also for what are the questions that you can directly answer, right? Chalo guys. So let's take the question number 6. So what's the question says? 2 particles of mass A and MA and MB with velocities VA and VB respectively, so collides. After collision, so they interchange their velocities. See here. So after collision, they interchanges their velocities. So if they interchange their velocities, the 2 bodies are going to be identical. Then we can say that 2 bodies are identical. They interchange their velocities means their masses are equal. The 2 bodies are identical. So that means their masses are equal. MA is equals to MB. So then they are asking what is the ratio of MA by MB. So the MA by MB is equals to simply 1:1. So which is nothing but, so option 4 is the correct answer. 1:1, which is 1. Understood guys? Simple thing. Chal. So let's go for the next question. So NEET 2016, APMT 1994 and 1991. So what's the question says? two identical balls. So what does it mean by identical balls? Having the same mass. So A and B, they both have the same mass. So have the velocities 0.5, this is moving 0.5 meter per second, and then so this moves 0.3 meter per second, because they said minus means they moves to the left. So collide elastically in one dimension. So then the velocities of B and A respectively after the collision. So see, this is A, this is B. So A, B. So I can simply say that, so the body B velocity will be body A velocity. So this moves with a velocity of 0.3 and this moves with a velocity of 0.5. So therefore B and A respectively, they said. So B and A respectively. So what is the B velocity? 0.5. So B velocity is 0.5 is there in this and in this. This option and this option you can eliminate. So 0.5 is there in this and in this. So now which one to consider, sir? 0.5 right side. This moves to the right side. 0.5 initially. So its same velocity and direction will be shifted to the second body. So which is 0.5. The right side is the correct answer, which means its velocity is going to be 0.5 and A body velocity is going to be minus 0.3. Okay, understood? Chalo. So let's take the next question. So what's the question says? Two identical ball bearings are in contact with each other and resting on a frictionless table are hit head on by another ball bearing of same mass moving initially with a speed v as shown in the figure. So if the collision is elastic, so which of the following is a possible result after the collision? See, this is the diagram first. These are the options. A, B, C, D are the 1, 2, 3, 4 are the options. So this is the diagram. So first let me explain you the question. So there are two identical ball bearings. They are in rest. So here these two balls are in rest initially. These two balls are in rest. Okay. So this is moving with v velocity. So all these balls are identical. So then see here. So if it comes with velocity v and hits this one, so what happens? Its velocity will be imparted to this. So its velocity will be imparted to this. And then it hits the next one immediately because they both are in contact. So then its velocity will be imparted to this. So that means its velocity will become v. And then these two velocities will become 0. So check the option. So first its velocity will become 0. So they both move with the v by 2. No, the velocity will not be shared between those two. So here the first one velocity and second one velocity becomes 0. Yes, the third one will have the velocity v, correct. And so all three v by 3, no. So v by 1, v by 2, v by 3, no. See here, the simple logic is, it is moving with v velocity. So they all identical. So it imparts its velocity to the second body. So then again the collision happens here between these two. So its velocity will be imparted to this one. Yes. So that means the final body, third body gains a velocity v. So these two comes to the rest. Yes or no? So that's what. So the final body gains a velocity v and these two comes to the rest. Clear guys? Understood? Everyone? Just a minute. Done? Sure. So next. So try this question. So what's the question says? A ball moving horizontally with a speed v strikes a bob of a simple pendulum at rest. So the mass of the bob is equals to that of the ball. So if the collision is elastic, so the bob will raise to a height. See here. So simple question. So this is of the ball of mass m, and here is a simple pendulum whose bob is of same mass. So this ball and the bob mass is all same. So if it is a mass m, this is also mass m. So now it is moving with a speed v. It is moving with a speed v. So it comes and hits this one. It comes and hits this, and then it raises to some height, right? So it raises to some height. So what is the raise in height they are asking? So what is this raise in height? Simple question. First, the first thing is, so this body is moving with v velocity. So when the collision happens, So it gains a velocity v and it comes to rest. The ball comes to rest. So this bob of mass m gains a velocity v, right? So that means, so shall I say that let's apply the conservation of mechanical energy. So the Ke initial plus potential energy initial is equals to Ke final plus the potential energy final. Yes or no? So once it reaches to the maximum height, its potential energy will become 0. Initially this bob of mass m has a velocity v, so its initial kinetic energy is half mv square, and then initial potential energy is 0, because consider this as a ground. Consider this point as a ground. So the only thing that you have to understand here it is, so this ball, this is initially at rest. This is initially at rest. So then once it comes and hits this one, so it gives its velocity to the bob of mass m, because these two are identical. Yes or no? So then its velocity will be given to this. So it moves with a velocity v and raises to some height h. So what is that height we have to find? So I am applying between these two, I am applying the conservation of mechanical energy. So the initial kinetic energy is half mv square, initial potential energy 0. Finally it comes to rest, so final kinetic energy 0. So and it raises to a height of h. So mgh is a potential energy. So from here I can write half mv square is equals to mgh. So I need h here. So m cancel. So h is equals to v square by 2g. h is equals to simply v square by 2g. So check the option, v square by 2g. Option 2 is the correct one. Clear guys? Understood? Chalo. So let's move further. So the question number 10. So what's the question says? A bob A of pendulum of mass m released from the horizontal to the vertical hits another ball of pendulum or same. Okay, what is the speed? So starts moving. See here. So the simple question: a bob of A of pendulum of mass m released from horizontal. So initially the bob of mass m here it is. So it is horizontally placed. So now it is released from the rest. So its initial velocity is 0. Then so same mass at rest. So here on the ground, so this is the ground, there is another mass, so which is attached like this, 1 meter length. So this is of mass m and this is also mass m, same mass. So if the length of the pendulum is 1 meter, so what is the speed with which the bob B starts moving? So it is released and it comes and hits this one. So once it hits this, so then it moves with some velocity v, it comes to rest. Yes or no? So simply again you can apply the conservation of mechanical energy. So the kinetic energy initial plus kinetic energy final is equals to, so potential energy initial plus potential energy final. So initially the kinetic energy is 0. This is initial position and this is final position here. So initially its kinetic energy is 0 because it is released from the rest. So its potential energy will be mg into h. So final potential energy, it comes to the ground 0. So then it attains a velocity v. After hitting, it attains a velocity v. So half mv square. So simple thing. So here you can cancel, mgh is equals to half mv square. So what do we need? V, right? So here m cancel. And then so height is 1 meter. The length of the pendulum is 1 meter. So then v square is equals to g is 10. So h is 1. So here v square by 2. So send this 2 also to this side. So v square is equals to 20. From here v is equals to root 20. So check the root 20. The closest option is between 4 and 5. So between 4 point something. So the correct option is 4.47 meter per second. Option A will be the correct answer. 1 will be the correct answer. Clear? Understood guys? Chal. So we don't need another slide. Chalo. So let's go for the next question. See, initially spring is at its natural length and collision is elastic. So then find maximum compression of the spring during the motion. So this question I'll explain. So the next 2 questions I'll give the homework guys, because those 2 are simple easy questions only. So this question I'll explain. See here. So initially the spring is at rest. So first thing is, so these are the 2 masses. Okay. So first this mass is moving with velocity v0 and then it hits this. So then it gains a velocity v0. Yes or no? Because these two are identical, m mass and m mass. So first let's write before collision. So let's write before collision and after collision diagrams. So before collision, this is a mass m, so which moves with a velocity v naught, and then so here this is a spring which is at natural length, so then this is of mass 2m. Yes or no? When it hits this, so it gains a velocity v naught. So this is a before collision. This is before collision. Now after collision, what happens? See here, after collision, so this is of mass m, and then so which moves with some other velocity u after collision. So just after hitting, first it gains a velocity v naught. So once it starts moving, its velocity changes. Let it be u velocity, and then so the spring compresses. The spring compresses, and then this the 2m mass also will move with the same velocity u. So this and this will move with the same velocity u after collision, because these two are same system, right? So v naught, and after the collision, so they both move with the velocity u. So now let's write the conservation of linear momentum. The p initial is equals to p final. So what is the initial momentum? So the initial momentum before collision is m into v naught is equals to, so the final momentum. So for the mass m, its velocity is u, and for the mass 2m, its velocity is u. So 2m into u. So from here, so m cancel. So v naught is equals to u plus 2u, which is 3u. So that means u is equals to v naught by 3. U is equals to v naught by 3. So which means, so this moves with a velocity v naught by 3 after collision. So this also moves with a v naught by 3 after collision. So now let's write the conservation of mechanical energy. So the initial, again I am drawing the diagram. So this is of mass m, so which is moving with some velocity v naught initially. So this is of the spring which is at its natural length. So then this is of 2m mass, right? And then so after collision, this is before collision. This is before collision. And then after collision, so this is of mass m, and then which moves with the velocity u. So then the string will be compressed, right? So this is of mass 2m. The spring will be compressed. This is of mass m. So this is also u. So which is, this velocity is v naught by 3, and this velocity is also v naught by 3. We already calculated that. So this is a after collision, right? So now understand the concept. So let's apply the conservation of mechanical energy. The initial kinetic energy plus, so initial potential energy is equals to final kinetic energy plus final potential energy. So initially it is moving with a velocity v naught. So that's why half m v naught square is the initial kinetic energy. So the spring is at its natural length. So the spring is at its natural length initially. So there is no potential energy stored in the spring. So initially. So now here spring compressed by, here spring compressed by the displacement x. The spring compressed by the displacement x. So I can write, so the initial potential energy is 0. So final kinetic energy. So this block, small m block mass, will move with a velocity v naught by 3. So half m v naught by 3 whole square, it will possess the kinetic energy. And second block is also moving with the velocity v naught by 3. Half into its mass is 2m into velocity is v naught by 3 whole square. Plus, so the spring is compressed, so that what's the potential energy stored in the compressed spring? Half kx square. We already studied that. So from here, I can first cancel half, you can take out. So cancel, 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 half. So here m v naught square is equals to, so m here v naught square by 9 plus, so here it is 2m into v naught square by 9 plus kx square, right? So we need actually x, right? So send this term to this side. So m v naught square, first let's write, so 9 is the LCM, m v naught square plus 2m v naught square, which is 3m v naught square. Yes or no? So m v naught square plus 2m v naught square plus kx square here. So 3 1s are 3, 3s are. So send this to this side. So kx square is equals to m v naught square minus 1 by 3 mv naught square. So then if you take the LCM here, so kx square is equals to, so 3 is the LCM, so 3 mv naught square minus mv naught square, which is 2 mv naught square, right? So from here send k2 also that side, so 2 mv naught square by 3k from here. So the x is equals to, so root over 2m by 3k, so into, let's write v naught outside, so x is equals to root over 2m by 3k, so root over 2m by 3k into v naught. Option 1 is the correct answer. Clear guys? Understood this question? Chal. So the like bit complicated one, so you just understand the procedure how we did. Done? Chalo. So let's move further. So a ball is moving with velocity 2 meters per second towards a heavy wall, and wall is also moving towards the ball with a velocity 1 meter per second. So here the wall is not at rest. So assuming the collision to be elastic, find the velocity of the ball after the collision. So can you guys take this as a homework? The simple question. We have to find, so find the velocity of the ball, v1 after collision we have to find. So just write the v1 formula and substitute it. Okay, chalo. So take it as a homework. So a proton of mass mp collides with a heavy particle which is of mass which is at rest. So after collision, proton bounces back with 4 by 9 times of its kinetic energy. Kinetic collision is perfectly elastic. So find the mass of heavy particle. So take this as a homework. Simple question again. So these two questions, just try it on your own. If you are not getting, I'll solve them in the next class. Okay. So clear guys? That's it from my end for the today's session. So write the short notes guys. After every lecture, write your own short notes. That's important. So in the next session, we'll discuss about the inelastic collisions and coefficient of restitution concept. Okay. So till then, keep studying. All the very best. Bye.